Good morning, teacher and everyone in class. My name is Visarut Athayilan, or you can call me in shortly Pitun. I am pleasant to be here today to talk to you about Frobenius or Frobenius method. Attention to Association Professor Sinina Chongkong. It's up to you to say Frobenius or Frobenius. Okay, in my presentation today, I'm going to explain Frobenius in three parts. Firstly, who is Frobenius? We talk about biography and base known for his contribution to the theory. And the second part, what is Frobenius' method? We talk about the ordinary point and analytic function, the method of Frobenius, and way to find infinite series solution for a second order of ODE. And the last of presentation is how to apply Frobenius' method in the problem 1. Okay, who is Frobenius? The full name of Frobenius is Ferdinand George Frobenius. He was born on 26 October 1849 until he died on 3rd of August 1917. He was a German mathematician best known for his contribution to the theory of elliptic functions, differential equations, number theory, Frobenius method, and to glove theory. Alma mater of old University of Frobenius is University of Göttingen and University of Berlin, all the university in Germany. What is Frobenius method? The fx or function is analytic function. At x0, when function can be rearranged in terms of Taylor series to the x0 in the general term of Taylor series in rectangular. Okay, and series solution of ODE, its general term is y double plum plus p of x, y plum plus q of xy equals 0. x0 is an ordinary point of y double plum plus p of xy plum plus q of xy equals 0 when p of x and q of x is an analytic function at x0. Okay, first, a point that is not an ordinary point is said singular point. And second, a singular point is regular singular point when x minus x0 multiplied by p of x and x minus x0 to the 2 multiplied by q of x is analytic function. Okay. Okay, the step of check the analytic function and ordinary point. We don't have many time to explain. You can pause the video or you can come to the understand later. Okay, we talk about the Frobenius method. The theory said if x equals x0 is regular singular point, the differential equation in general term is y double plum plus p of x y plum plus q of x y equals 0. The method of Frobenius is to seek a power series solution of the form y equals x minus x0 to the r and a0 plus a1 x minus x0 plus a2 x minus x0 to the 2 can rearrange in the series term y equal the sum of n equals 0 to infinity of a n x minus x0 to the n plus r. The recommend a0 is not equal 0. Okay, and after that we differential the y term, we get y plum equal the sum of n minus 0 to the infinity. The exponent n plus r multiple a n x minus x0 to the n plus r minus 1. And after that we do the same, we get y double plum equal the sum n plus n equals 0 to the infinity n plus r, the same term, and after that the exponent from the y plum, and a n x minus x0 to the n plus r minus 2. Okay, let x0 equals 0, we get y equal x to the r a0 plus a1x plus a2 x squared to the infinity. We recommend a0 not equal 0. We get the power series. The sum n equals 0 to infinity a n x to the n plus r. Okay, at x equals 0 is regular singular point of GDE, general differential equation, because x and p of x and x squared q of x is analytic function at x equals 0 point. X equals 0. So x p of x equals p0 plus p1x plus p2x squared to the infinity, and x squared q of x equal q0 plus q1x plus q2x squared to the infinity. Hint, we said we recommend q0 equal x squared q of x and p0 equal x p of x when x equals 0. When x equals 0 in the two equation, 0 with negligible term equals 0 because term of equals 0. We get this. Okay. After that, we multiply both sides of GE by x squared. The GDE is y double plum plus p of x y plum plus q's of x y equals 0. After we multiply by x squared, we get, and we rearrange in the second term, x squared equals x times x, and we substitution in the rectangle from last page. Okay, we get y in the series, power series, y equal to sum n equals 0 to infinity of a n x to the n plus r, and we differentiate the y, we get y plums equal to sum n equals 0 to infinity n plus r a n x to the n plus r minus 1, and we do the same, we get y double plum equal the sum of n equals 0 to infinity n plus r multiple n plus r minus 1 times a n x to the n plus r minus 2. Okay. After that, we substitution all y plum, y plum, and y, and all GDE. Okay, we get 0 equal x squared, substitution from y double plum and p term, and this y plum and this y term. Okay, we rearrange and okay, we say a and x n to r. We pull the a and x to the n plus r from the bracket. Okay, we substitution n equals 0 in the last equation from last page. We get n 0, 0. Okay, we got the equation. This, the summation start begin n equals 0. in this term, n equals 0, and plus n equal 1 in the second term. The term of x at lowest exponent is x to the r. The coefficient is 0 x to the r. Hint from large page. Use. Okay, we get r minus 1 plus p0 r plus q0 in the bracket times a0 x to the r. Let the large term equal 0. We get r squared plus p0 minus 1 times r plus q0 equals 0 is initial equation. The root r1 and r2 is exponent. Okay, we conclude the step to explain the Frobenius method and the way to find an infinite series solution for a second-order ordinary differential equation. And the general term is y double prime plus p of x y prime plus q of x y equals 0. At x equals 0 is regular singular point it means. The general is all x equals 0. Okay, q0 equal x squared q of x and p0 equal xp of x when x equals 0. We get the initial equation, and we let y1 equal the sum n equals 0 to infinity of a n x to the n plus r1, and y2 equal the sum n equals 0 to infinity b n x to the n plus r2. We conclude the step when the r1 minus r2 is integer and r1 minus r2 not member of integer in the two part. When r1 equal r2, we calculate y1 and use y1 to solve y2, and this equation we get y2. And if r1 not equal r2 and r1 less than r2, we choose r1 to solve y1 and choose r2 to solve y2. The answer have two ways. One way is y1 and y2 independent, and y1 and y2 dependent. Okay, after that we substitution y1 and y2 in the general solution is y of x equals c1 y1 plus c2 y2. Okay,